we're going to start with finding the domain of a rational, which is something that we've done before. So remember that a rational function is special because its denominator cannot be 0. So here, in order to determine what its domain is, I need to know what values would make this denominator 0. So I'm going to say, okay, well, where does 4w squared plus w minus 9 equal 0? Let me see if I can pull this up just a little bit. Now we're going to ask ourselves, does this factor? 4 times 9 is 36. Are there two numbers that multiply to negative 36 and add to 1? I don't think so. 36 is, nope. So then we'd have to use the quadratic formula on this one. So w equals a negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a one squared minus 4 times 1 times negative 9. It's the square root of 37. And that 37 is prime, so that means that that radical doesn't reduce. So in set notation, you would say that w is all real numbers except, they want you to split it. So negative 1/8 plus rad 37 over 8, comma, negative 1/8 minus rad 37 over 8. And then in interval notation, you would say all of the numbers from negative infinity until negative 1/8 minus rad 37 over 8. All of the numbers in between negative 1/8 minus rad 37 over 8. And so this one is continuing. Negative 1/8 plus rad 37 over 8. And then I'm going to continue this down here. Unioned with negative 1/8 plus rad 37 over 8 to infinity. So it's all the numbers to the left of the smaller ones, everything in between the two, and all of the numbers to the right of the bigger one.
I have a quick question because I got a little bit confused I think like last week you did where we did the quadratic formula, but there were too many negatives. So we like moved the signs around.
Yeah, so if there was a negative on the bottom, when you split this, a negative 1 over a negative 8 would have been a positive 1/8.
Okay.
But the plus or minus would have been unaffected by this being a negative.
Okay.
Okay, so let's review polynomials real fast because we have to do the exact same thing here. So we need to figure out where does this whole thing equal 0. So with the polynomials, the first thing that I always do is graph them and see if I can get any zeros from the graph. 8x to the 4th, 34x to the 3rd, 25x squared, 52x minus 60. Is that right? Looks good. Looks like I have 1. and I have a 1 at 2. That one might be. So one of the things we talked about was bounce versus straight versus curve, right? That one might be a bounce, which means that we might have had like an a minus 2 squared like that. And we can check that. So we know for sure that it is there once. If it looks like a bounce, then it's worth checking it twice. I don't need pluses. 25, 52, negative 60. And then we know it goes through at 2. Multiply, add, multiply, add, multiply, add, multiply, add. Okay, so what I mean by check it twice is, you know for sure it was a 0 if it went unevenly, there was no remainder. I'm going to check to see if this is a 0 twice by checking the 2 again. 16, negative 2, negative 4, negative 15. So it is there twice, which means that I was right. And even though you can't really see it, this is a bounce. So if it's a bounce, then that means that your 0 repeats twice. If it's a curve, then that means your 0 repeats 3 times. And if it goes straight through, then your 0 doesn't repeat. It's only there once. And so now we said, remember, this is my remainder. This is my constant. This is my just 1. And then this is my squared. So now of this, I can either factor or use the quadratic formula. So 8 times 15 is 120. Are there 2 numbers that multiply to a negative 120 and add to a negative 2? Yes, there are. 12a, a minus 12a, and a positive 10a. Multiply to negative 120 and add to negative 2. Okay, so a 8a squared and a 12a squared have a 4a. And then a 10a and a 15 have a 5. Oops, minus 3. And they both have a 2a minus 3. And then that leaves me 4a plus 5. So then these are going to be my other 2 zeros. So 2a minus 3 equals 0. Move over the 3 and divide by 2. 4a plus 5 equals 0. Move over the 5. Divide by the 4. So a is a real number, and a does not equal negative 5/4, 3/2, or 2. And then in interval notation, it would be everything. I'm going to write it above the box because I know I'm going to go past the box. It would be everything to the left of negative 5/4, everything in between negative 5/4 and 3/2, everything in between 3/2 and 2, and everything to the right of 2. I don't know why I can't draw an infinity symbol right now. There you go. And I don't think that he gave you any crazy polynomials on here. Already factored, already factored, already factored, already factored, already factored. That one you can factor by grouping. All right, so there's one crazy polynomial. You'll have to do what we just did on here once. All right. Okay. So the horizontal asymptote happens when your denominator equals 0. So to determine where the horizontal asymptote is, you set your denominator equal to 0 and you solve. So when we draw this in, we're just going to draw a vertical line at 3. Oh, they wanted horizontal. That was vertical. I definitely just got ahead of myself. All right. For the horizontal asymptote, now that I'm actually reading the instructions, there are 3 cases. If your degree is bigger on the top, then you don't have a horizontal asymptote. If your degree is bigger on the bottom, then your horizontal asymptote is y equals 0. If they have the same degree top and bottom like this one, then you use the leading coefficients. So here, leading is a -2, and here, leading is a 1. So your horizontal asymptote would be at y equals -2 over 1, which is just -2. So that's your horizontal asymptote. So bigger on the top, there is not one. Bigger on the bottom, y equals 0. And if they're the same, you use the leading coefficients. I'm going to drag this over here for myself. Okay. All right. So another way to talk about horizontal asymptotes is that it is the end behavior of a graph. So this, as x approaches, if you were asked the end behavior of this graph, you would say as x approaches positive infinity, y approaches -2. As x approaches negative infinity, y approaches -2. See how it's going toward -2, both left and right? So that would be the end behavior.
Hey Jess, I was just thinking about the video lessons, and when Andy does the video lessons, he does as x goes to -infinity on the top line, and x goes to infinity on the bottom.
So
I think that might be where some of the things get mixed up a little bit.
I do it this way because that's the way Moore does it. So I apologize.
I just happened to notice. I'm like, why do I keep putting it like that?
And that makes sense because, like, if you look, you see how this says, this is one of the questions from your homework. Now, you know, we all get different examples, but you see how this says right hand and then left hand?
Right.
So I understand it makes more sense in my brain to do left and then right because that's the way the number line works, right? But Moore asks for right hand first. So I have gotten in the habit of doing right hand first because that's what Moore asks for.
Right.
So
Tricky.
Yeah, I apologize. I'm not trying to mess you up. I know Andy's not either, but.
No.
Okay. So end behavior, again, is just another way of asking about the horizontal asymptote. So I said if the degree is the same top and bottom, see how these are both degree 2, then you use the leading coefficients, which here would be just 1 and 1. So this would be y equals 1. You have a larger degree on the top here than you do on the bottom, so there is no horizontal asymptote. And here you have a larger degree on the bottom, so your horizontal asymptote is y equals 0. If it's bigger on the bottom, it is always y equals 0. Okay, and I just double checked, and like this question is a drop down, and those are your 3 choices. Okay. So then that end behavior, if we were going to continue looking at it, again, is determined by the degree of the top and the bottom. So here we have a degree 10 on the top and a degree 4 on the bottom. That means it's bigger on the top. So that means that this horizontal asymptote does not exist. Bigger on the top means your horizontal asymptote does not exist. Now, for a question like this, honestly, to determine what's happening left and right, I would graph it in my calculator. I'm sure that he would tell you that there's like, you can deal with the negatives and blah, 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 but like, I don't know about you, but I paid a lot of money for this calculator, so I'd like to make it work for me. Not negative 14. 14x minus 2x to the 10 plus 2. So this one looks like it goes up on both the left and the right. So on the right, as x approaches infinity, h of x also approaches infinity. As x approaches negative infinity on the left, h of x also approaches negative infinity. No, it also approaches positive infinity. Sorry. See it?
How did we determine that the asim thing doesn't exist?
Bigger degree on the top.
Oh.
Okay. I am going to, before we are done tonight, I want somebody to remind me. When I told you guys I've been teaching this class too long, right? Too long. So there was once, many moons ago, where is it? I gotta find it. Where I was teaching this class, and for whatever reason, people were just not like getting these rationals rules. There it is. And so I took a piece of paper and I wrote down all of the rules of rational functions that you need to know. See how that's my handwriting? What I'll do is I will put this up in the 7.3b, you know, where I normally put the in-class examples. I'll put this there. And then that way you have one page with all of your rationals rules. So like you see how I'm pointing at my monitor, like you can see me. You see how right here, these are your horizontal asymptote rules. Bigger degree on the bottom means you have a horizontal asymptote at y equals 0. Same degree top and bottom, you use the leading coefficient over the leading coefficient. That's what LC stands for. Bigger degree on the top means there is no horizontal asymptote. Okay? So I'll make sure I put that up for you before I log out tonight. That way you have it.
Thank you.
You're welcome. Yeah, I remember that class. They were like, we just don't know. It's too many rules. I was like, it's not too many rules. It's 6 rules. Stop telling me it's too many. 6 is not too many. And they were like, 6 is too many.
Guys, I'm just curious. Jess, I noticed that your screen is freezing a lot as you're going over things, and I'm wondering if it's my Wi-Fi or if anybody else is noticing that there's some freezing happen. So it's kind of like hard to follow along with what you're saying and what you're doing. Anybody? Yes.
Yeah, it's not just you. I think it's just the connection.
Okay. Thank you.
All right. I am running a speed test And it's not, like, it looks like it's okay on my end. So I'm sorry. Oh, never mind. My upload speeds suck. All right. I'll make a note that I need to restart my router, my modem, after we're done. Because that's probably what the problem is. Sorry.
Thank you. Thank you.
Okay. So here, if you're in factored form, to find the degree, you add the degrees of the factors. So the degree on the top would be 3 plus 7 plus 6 plus 8. I don't know why I'm doing this in my calculator. It's 24. So the degree on the top is 24. The degree on the bottom is 5 plus 7 plus 5 plus 4. Ooh, I did times. 1 plus 7 plus 5 plus 4. The degree on the bottom is 21. So again, we have a bigger degree on the top. So again, I'm going to say D and E. And I'm going to see if I can get a graph out of this. There you go. Negative 3x to the third. Nope. X minus 4 to the seventh. X minus 8 to the sixth. X plus 7 to the 8. Again, make sure that you do parentheses around your whole numerator and denominator. X to the fifth. X minus 4 to the seventh. X plus 7 to the fifth. X plus 6 to the fourth. We could have canceled so many of those. Hey, there it is. It's back. All right. I think the table might be more helpful here than the graph. So as we go into, do you see how these are getting bigger and bigger and bigger? The y values? Bigger and bigger and bigger and bigger. So as x on the left hand, as this is a t, as t goes to negative infinity, p of t also goes to positive infinity. See it? As these numbers get more and more negative, these numbers are just getting huge. And then let's look at the right side. Okay, here we go. Oh, look at that. You see how these numbers are getting more and more and more negative? So as t goes toward positive infinity, p of t goes toward negative infinity. Okay. So that's 3.1. And then in 3.2, we start talking about vertical asymptotes, which I accidentally did before. So vertical asymptotes, you set the denominator equal to 0 and solve. So my vertical asymptote here is at a equals 3. And now here, the intercepts are where the numerator equals 0. The first thing you should always do with these, though, is check to see if anything cancels. So here you see how we have a 7r minus 4 on the top and a 7r minus 4 on the bottom. That makes a whole. And that whole would be at 4/7. Now, to figure out the y value of that whole, we take this and we plug it in to the after we've reduced function. So let's see. I'm going to plug it into the numerator. -7 times, what did I say, 4/7? Yep. 4/7 minus 5 to the third times, 4/7 minus 6. And then we're going to divide that by 5 times, we need another set of parentheses, 5 times 4/7 plus 7 to the third, 4/7 minus 8. What does it say? Do not do any rounding until the final answer. Well, that was my bad because I think I got ahead of myself. So here, if you have, oh no, never mind. I was about to say something that's not true. So this would be 4/7 negative 0.556. So you should always look to see if you can reduce first. And if you can reduce, then you have a whole at the place where you reduced. Ooh, you know what? I think I see what I did. Hang on. So I had that. I missed a parenthesis right there. I don't know if that makes a difference. Let's see. Nope, it doesn't. Yep, okay. So then to find the intercepts, you set whatever is left in the numerator equal to 0 and solve. So -7r minus 5, just the factor. So -7r equals 5. R equals -5/7. And then r minus 6 equals 0, so r equals 6. To find the vertical asymptotes, you set whatever's left in the denominator equal to 0 and solve. So this would be 5r plus 7 equals 0. 5r equals -7, r equals -7/5. Now these are not points. These are vertical lines. So you're just going to put those values. R minus 8 equals 0, r equals 8.
We're setting the factors in the denominator equal to 0?
Yes.
Okay, thank you.
And then to find the h of r intercept, that is where you would make all of your r's 0. And again, you can do that to the after you've reduced version. So this would be, well, -7 times 0 would just be -5. -5 would just be -5 to the third. And then this would just be a -6. And then we're going to divide that by, again, this is 0, right? So we get 7 to the third. And then this is 0, so that's just 8. -8. Let's round that one. So -2.73. -0.273. So on your written assignment, you are also asked, that's everything that you have to do. This right here, the horizontal asymptote plus this, that's what you have to do. And then you're also asked to graph. So what I would do, if this were me and it was my graded assignment, is remember that you're doing this for me and I'm a human, so I don't expect perfection. So if we do 1, 2, 3, 4, 5, 6, we know that we cross at 6, and we know that we cross at -5/7. So that's going to be like here-ish. We know that we cross the y-axis at -0.273, so that's going to be like here-ish. We know that we have vertical asymptotes at 4/7, so that's going to be around there, and 8. I'm going to draw all those in. X equals 4/7, x equals 8. Right? Do you want to know what I'm going to do next? I'm going to put this in my calculator. And I'm going to figure out what the rest of it looks like after I've put everything in that I found algebraically and labeled it. I'm literally going to take this and put it in my calculator the same way I did the other ones, and I'm going to copy down what I see. So that's my advice. And if that means that you have to play around with your window settings to be able to fit the whole window, then go for it. You know what kind of window you need because you can see like what your constraints are right here.
Miss Jess?
Yeah.
Would you mind telling me one more time what we're doing to get our h-bar intercept?
You make x 0 or r 0. Okay.
Thank you.
All right. So again, to find the t-intercepts, you need to set your numerator equal to 0 and solve. With a polynomial, for me, that always means graphing first. So I'm just going to graph the numerator. Five x to the third plus 6x to the second, 29x minus 6. That's a good one. Is that 2 and 3? -2 and 3. There's a 0 at 2, -3 and 2. Okay, so I honestly might need some extra room. So here we go. I have 5, 6, -29, -6. And I got -3 from the graph, and I got 2 from the graph. See them? Those are the places where y equals 0. So I'm going to take those out. -3, -15, that's going to be -9, +27, -2, 6, 0, and then a 2. That's 10, 1, 2, 0. So this is my remainder. This is my constant term, so then this is just an x. So to find my third zero, that was this one right here. See how it looks like it crosses at 0? It doesn't. It crosses at -1/5. So then my 3 t-intercepts are -3, 0, 2, 0, -1/5, 0. Now, to find my vertical asymptotes, I set the denominator equal to 0 and solve. So again, with a polynomial like this, for me, that means graphing first. 10x to the 4th, 33x to the 3rd, 13x squared, 24 plus 24x plus 4. Oh, that's a minus. Okay, there we go. Okay. So you see how it bounces at 2? Remember we said that if it bounces like that, 2 is a 0. And if it bounces like that, then that means it repeats. So I know that I have 2 twice. 10, -33, 13, 24, 4. 2, 20, -13, -26, -13, -26, -2, -4, 0. Then since it bounces, I do that again. 27, 14, 1, 2, 0. Okay. So then I'm left with, this is my constant. This has just a t, and this is my t squared. Now I want to see if I can factor this. 10 times 1 is 10. Two numbers that multiply to 10 and add to 7 are 5 and 2. So a 10t squared and a 5t have a 5t in common. A 2t and a 1 only have a 1 in common. So then that would leave me with that 2t plus 1 and 5t plus 1. So 2t plus 1 equals 0. 5t plus 1 equals 0. And so then those are my 3 horizontal asymptotes, vertical asymptotes. -1/2, -1/5, and 2. Now, you cannot have something be both an intercept and an asymptote. As I'm sure Andy explained to you in his video, an asymptote is a line that the graph never crosses. And an intercept is a point where it crosses the x-axis. So if you see the same number as an asymptote and an intercept, that means that it is neither of those. And instead it is a whole. And so to find the y values for these, this in its factored form, my numerator, would have been x plus 3, x minus 2, and this 5x plus 1. My denominator in its factored form are these two, and then x plus 2 and x minus 2 and x minus 2. See it? How I got these two from factoring this, and then this one, and this one. So, oh, those should all be t's. Sorry, I hate it when they're not x's. So then that was 2t plus 1, 5t plus 1, xt plus 2. No, I did that again. T minus 2, t minus 2. So one of these t minus 2's cancel. And this 5t plus 1 cancels. And I'm left with t plus 3 over 2t plus 1t minus 2. I'm not sure how I'm going to find my point for that one. At the ordered pair. Let's try 1/5 first then. So remember I told you to find the hole, we would plug that negative 1/5 in. Negative 1, what did I do? Negative 1/5 plus 3. I don't know why I did 2 parentheses, I only needed 1. Divided by, I need 2 parentheses on the bottom, 2 times negative 1/5 plus 1. Negative 1/5 minus 2. 70, negative 70 over 33. Now, honestly, since this one repeats, we can't plug in the 2. We're going to get 0 in our denominator. So I'm going to put that one there. I think this might just be an asymptote, but since I'm not sure, you know what I'm going to do? I'm going to graph it, and I'm going to look at it. 5x to the third, 6x to the second, 29x. I've honestly never seen an example where you have a repeating root like that winds up canceling on one side but not the other. 33 x to the third, 13 x to the second, 24x. And so I want to see, I'm interested to see what happens here at 2. It's an asymptote. So since it only canceled once, that 2 stays an asymptote. And then to find the y-intercept, we do the same thing that we did before where we make all of our t's 0. But if I make all of my t's 0, everything goes away except for this negative 6 and this 4. So that would be and so again, I understand that graphing these things is a pain in the butt. I get it. I really do.
The
So
whole thing is a pain in the butt.
so here's what I want you to keep in mind. We know that we have an intercept at -3, 0. We know that we have an asymptote at 1/2. We know that we have an asymptote at 2. We know that we have a hole at this random ordered pair. We know that we have a y-intercept at 0, -3/2. Label all of these, like literally label this, and then pull this up and go, okay. All right, don't do anything fancy on your sketch. Use the calculator. It's there to help you. Okay, so writing an equation is actually easier than what we've done. Here, if you have a 0 at 0, we said that the zeros were the numerator, so the places where it crosses the x-axis. So that means that in your numerator, you have an x minus 0 and an x minus 3. And then the vertical asymptotes tell me where my denominator factors are. So here, if you have a vertical asymptote at x equals -1, then you have a factor in your denominator of x plus 1. A vertical asymptote at 5 means x minus 5. And like, I'm 98% sure that's all it wants, but I'm going to go back and double check right now. I know that it would probably want you to make this x. But they didn't really give you any other points. Squared. Oh, okay, I see. All right, so the horizontal asymptote. Okay. Here we see that we have degree 2 on the top and degree 2 on the bottom. There are 2 factors here and 2 factors here. That means that your degree top and bottom means that you would use the leading coefficients in order to find your horizontal asymptote. And your horizontal asymptote here is at 2, which means that it would be 2 over 1. So you would need a 2 in the front on the top and a 1 in the front on the bottom. But you wouldn't put a 1 in the front on the bottom. Here it is. Yep, and that's what you have to do. So this is your final answer for that one. So again, the x is because it crosses at the origin, x minus 3 right here, x plus 1, x minus 5, and then the 2 is because the horizontal asymptote had to be 2. And so writing the function given information is basically the same, where if they tell me that we have a vertical asymptote at -2 and 1, then that means in my denominator, I had factors of x plus 2 and x minus 1. If they tell me intercepts at -5 and 5, then that means I have x plus 5 and x minus 5. A horizontal asymptote at y equals 4, that would be the same as 4 over 1, which means a 4 in front in the numerator and a 1 in front in the denominator. And again, I'm going to just make sure that they don't want you to... Nope, that's how they want you to leave it. I wanted to make sure that they didn't want you to like FOIL this together and get a polynomial, but they don't. They want you to leave it, or in standard form. They want you to leave it in factor form. So that's your answer. So again, I'm going to put this up right now. That is all of your, this is everything you need to know.
Can it be a little bit more clear?
What do you mean?
I can barely read it.
Okay, well then do this. Ooh, I zoomed.
Still looks like crap.
Okay, well that's my handwriting. That's, you're going to have to deal with it. If you don't want it, don't download it. All of this should be in the notes that you had to write down for Andy anyway. So if you want to use your notes, use your notes. I was trying to give you one place where everything was like in a list like that.
Thank you.
Okay.